Hello everyone, it is Mike Levin on Tuesday, April 13th, 2021, and it's SQL time. This is a video I've been putting off for quite a while because I've been putting off SQL for quite a while. I have a love-hate relationship with SQL. I love the tech, and I hate the implications, which is long-term support of live data, which turns you into a DBA, which is a second career on top of whatever else you do. And it's a phase everyone goes through in their tech career, that they launch something. It's got to be database back-ended, and oftentimes SQL is chosen as the protocol. It's not a particular database, it's more of an API for interacting with databases. So SQL is a API, application program interface, to a tabular, which is rows and columns, data structure. There's a SQLite built into many things. We can use too. It's serverless, meaning it's embedded, meaning it's simpler. And we're already using it in the tutorials I'm giving you down below, where I have a little name value pair database stuff going on. And I figured first I would show you a little bit about where we are right now. You can see I'm doing the overhaul to eventually move this back into a branch, or the main branch of the Pipulate directory. I am rebasing Pipulate, even though it's currently called SEOML. In very short order, it will be back to Pipulate. And I've started including instructions in here, and I'll take you through those instructions later. Things have gotten a little bit longer. It's still the same in spirit, but I'm covering more edge cases, and things take on those curly cues and stuff that show you it has really thought through all the various edge cases that, really it should deal with. If you deal with every edge case, it gets bloated and unwieldy. So it's striking this nice balance I talk about, setting up the data collection keys and databases for persistence with a key value pair. And that brings us really to where I want to begin. This right here creates this delete me database. You can see it's just 12 kilobytes, and I'm going to delete it, which you can really freely do. So I'll start running this from the top down. That's to turn on the PEP8 black code formatter. This is just for a little bit of this NBDev tool I use to help create auto documentation. This is some of the documentation I've put in line, and now the action really begins. You can see I have site equals, which takes the place of input arguments now. So after you run the step, you can see that your site equals whatever you set up there in place of input arguments. If you ran this from the command line as a command line tool, you would similarly do site is the input you're providing. It's no longer file name and description. It is real application now. I also make that be the actual namespace for the databases that are coming right up. So this is the database. You remember it's a before and after. I deleted the deleteme.db. I run it, and deleteme.db. Where are you? Oh, Yep. go. I think I just got it right this time. My real site name. Oh yeah, I got it wrong. I put the wrong value in. So you can see how it created that directory. I'll just correct this here. Little things like this happen, but it really shows you what you'll be doing. I have to put that extra E in there. And then we go down to that database step again, which is this. This is before. There is no delete me in there. We run that. There's now a delete me in there. It's only the 12K. And this other stuff is in there from prior collections of Google Search Console data. And I'll show you that. First, we create all the arguments, and then we shape the input arguments the way it's convenient for data collection. Then we get our login credentials so that we can connect to Google Search Console. And now finally, we actually hit Google Search Console and we dump the data into GURLS. And you can see that has grown fairly big. This is the raw data collection, which is named the same as the name tuple data object I'm using as the API arguments to make the calls. And so that raw data is just about 2 megabytes worth of data, and I show some pretty output here. If it doesn't make a API call, it uses a period at the end. It uses a period at the end of a number it's going to display. And if it does make an API call, it's going to use an exclamation point. So without any further ado, you can see it sort of plow through all the days that are possible to collect in Google Search Console. That's the last 16 months worth of data. And you can see it got put into that same database. So that 2K file has grown just the tiniest fraction. 2 megabyte file has grown just a tiny fraction. And you can see here, as we scroll down on here, while most things have a period after it, because it's counting down from 16 months ago, right? 16 months ago was also 487 days ago. So 487 days ago, it's been cached, we already collected. 486, it's been cached, we already collected it. It's full of periods. But now when we get to 6 days ago, 5, 4, 3, 2, 1, suddenly we're hitting the API. Here are the little exclamation points that come after the numbers. So 7, 6, starting from, I haven't run this in a few days. All this work I had done quite some time ago, and I've just been hesitant to make the video because now I'm going to have to talk about rows and columns, tabular data, making commitments. So a bit of subtext here is that so far we've been using key value databases, which are also sometimes called NoSQL, which defers having to deal with tabular data for a while. So it's easy to do the data collection. It has deferred an important point. So data comes out. I have it breaking after one line just to populate one line of data so that we can take a look at it. So for one API request, it actually comes back with all the URLs that were active that day on the website in Google Search Console with all the metrics. And so we spin through the whole site all those days and we capture all that. We're just showing you the first one of, I could probably also show you the key. And you can see what key was being used once I unpickle it. So this is one of the older keys, right? So those URLs that were being shown, these are the input parameter that caused that data to be fetched. So one of the things we can do is, as we step through it, instead of dealing with the rows, all the rows and columns right away, I can deal with just the URLs. So for key in database, I'm going to, if it has rows in there, I am going to reach in to the first object under the keys subkey of the dictionary that comes back and add it to a set. So all URLs is equal to a set. And so you can add to sets, the API call for adding a set to a set so that it is both sets is .update. So without further ado, I just spin through that. I print a dot for each row. That's just the 400 and some dots. It has nothing to do with caching or not. It's all cached data now. There's no more, off-site API hitting. And then I can check the length of that, and it is 736 instead of the actual number of days, because it's multiple URLs. This is each day had a list of URLs. We gathered up all the URLs. We can look at it directly. Here are all the URLs, so you can see interesting things about my site. But I've shown this in videos so far before last time, and the new stuff is putting it into a row and column database and then maybe looking at it somehow. So this is kind of a spoiler here because that's the last time I actually performed this. And I could keep that there when I run it because I only conditionally create the table if the table is not already there. So you can start to see the, oh, that's the big one. I've got two of them here. I have just the URLs table, which becomes 60 kilobytes. And then I have the URL history, which becomes 1.7 megabytes. So I'm going to delete the URLs.database because that's what I'm about to create here. And you can see I'm creating the table if not exists URL, right? So you can see that thing I just deleted there was urls.db, right? So I name these table names in places like this, very similar to the data that's inside of there. So this is the create table command, and you can see there's some interesting stuff going on here. I'm starting to learn SQLite. So the first interesting thing is create table if not exists. So it's easy to throw in a create table statement, a gratuitous create table statement, which you would almost never do on a deployed scaled enterprise thing because you're not just making tables willy-nilly in your main app unless there may be temp tables. This is a main table of the app. I check if it exists. If it doesn't exist, I create the table with just one column. This is not even a two-column key value pair database. This is URLs, unique resource locations or locators. So every URL is unique and it is its own key. There's no key value pair. It's both the key and the data. So one column. It's of text data type, which is really just a suggestion because any column in SQLite can be text, integer, or float based on what you're attempting to put into it, or a blob, binary large object. And that field cannot support null, and it is also the primary key. And without row ID tells SQLite to not try and slip in an auto-incrementing behind the scene primary key column of its own, because when SQLite was made, so few people who were using this kind of tool really knew proper SQL that they wouldn't know how to create a primary key column. So the system stepped in and sort of did it for them. Without further ado, I guess I'll run it because this is just create the table. And then for every URL in that all URLs I just showed you a second ago, right? This stuff here, that's the all URLs. For each of those, attempt to insert into URL column the value URL from that iteration. There, that's into URL table, into these columns, the following values. So it's some strange syntax in SQL, very English-like. I run that. No output, but it did it. That 60K file came back. And in order to look at it to see it's really there, we can just do this. This just reads it back out, and you can see now this is coming from SQL. This is coming from a more traditional row and column type SQL database as opposed to a key value pair type database that I've been using SQLite for so far, using a third-party package, SQLite Dict. However, now I'm also using it as it's intended to be used as a row and column database. You want more rows and columns, and you want to see it through some sort of interface. Well, that's why I have this up here. This is Datasette, and it's sort of a web user interface to let you explore SQLite tables in read-only mode. Easily publishable to the web, and there's some cloud services out there where you can just plug a SQLite table and use Datasette and explore it without even using your local machine, but your local machine is fine. So on some of my talking head videos I did in the car, I was like, oh, primary keys in SQLite, I wonder how they're done. So I Stack Overflowed it up, and here is the syntax. Very simple. Create table something, name your columns, and then any of those columns can then be part of the primary key. To which I added some additional, stuff like suggested data types, and here's the primary key per that suggestion. But I also added without row ID to make sure that it uses my primary key and doesn't try and slip in its automatic primary key in the background. And pretty much the same as what you saw before, except that I'm handling all the rows and columns. So that's the create table statement, and then here's the executing of that create table statement. So if the table doesn't exist, it will be created. Table already does exist, so I'll let you see that 1780 become incrementally larger, and then I'll delete that table and run it again. So I run it, you'll see the same, 400 some dots, one for each day it's processing. And that doesn't look much larger because it's only adding URLs it hasn't encountered before. But now to see it, that way I did the data dump right here, isn't quite so easy with all those additional columns and stuff. It's better to see it in some environment that's, more row and column-y. So one way to do that is in a pandas data frame. So I import pandas as PD, as is the convention. And then I create a connection, which is SQLite.connect. And then that table sitting there right on the, it's more than a table, it's a database. I can have multiple tables, but I point to this guy right here from right here. And then I populated a data frame, pandas.readSQL query, select star from URL history using connection, right? Can you believe it? So I can put that data frame, I can populate a data frame with what was in the SQL table, and that's one way to do it. However, you're still limited to this kind of within Jupyter kind of interface. And if you wanted something, you can forget about these. I just did those for figuring out how to display my logo that's left over from that. But now that we have something sitting on the drive that we can do stuff with, we can, if you don't have it yet, you can pip install Datasette. Datasette. So if you haven't already, pip install Datasette. It'll show you that the requirements have already been met on my system. I'll cd into SEO-ML. And if I do an ls, you'll see that the database we're talking about, it's cd cache, ls, cd mike.lev.in, ls, and say we wanted to load this database here. And say hi, Charlie. Say hi to the people. Hello, people. Oh, he's purring away. DATASETTE space URL underscore history.db. Enter. Oh, a nice little database starts, right? So I guess we can copy that. Oops, I did a Control C, you see, so I can't Control C. I rerun it again. Don't let that ruin the demonstration. That's localhost 8001. So we can just go over here, bring up a new tab, localhost 8001. Hello, Datasette. Oh, there's a table called URL history. Let's look at that. We can select star from URL history. Okay, let's run SQL. Oh, nice. It's going to limit it to 1,000 rows just in case there's more than that in there. I don't even think there is in this database, but you can see now different things. You can get it as a CSV file. You can export it as JSON, or you could, do other type of SQL things. Let's see. I do believe that there's this Facet feature in here. So let's see if any facets are offered to me. Home. URL history. Oh, advanced. Suggested facets, clicks, and dates. So you can use a date facet. And then here are all the rows that exist on each date. So you can see how popular each day was in SEO terms. And I guess we can can't reverse the order. That would be nice. Column. Oh, you can say if the column equals something. And here are all the other things you can do. So greater than and less than. Now, I don't think these are real date formats. I mean, I know they're not real date formats. I used a text format to do that. Oh, you scroll down below, you have, then you can click on these different things. Yeah, well, there you go. You know, this gives you a general idea of what this tool is. You can queue up different filters and do different searching on your database, which, while not quite Excel, it does give you something that you can show the data locally on your machine and run ad hoc SQL without having to even mess with SQL in a Jupyter notebook. You know, it's easier. And then you can just deploy it, to a server in your local network or on a cloud service on the web, and give this ability to other people. It's read-only. It's very safe to do. And yeah, there you have it. Row and column use of the same tool we were using earlier for generic key value pair stuff. So I guess it's nice to see this diagram here. Yeah, I'll be making more diagrams like this that break down the individual steps. So this is kind of the overview of what we have in mind here, going from you being a noob, pushing a button in Jupyter to, do rapid iteration, playing things, trying, making mistakes, and customizing. And then eventually, when you have it right, thanks to NBDev, you get a .py file. That's a Python package, which you can parameterize, meaning sending it different site equals, date equals. It's not just one Jupyter notebook. It's every variation of parameters you can feed in. You test it, you get it to run like a Linux command, which is basically the same as parameterized, and then you can deploy it to the cloud. I show it here in the cloud. It can also be on Raspberry Pis or whatever. It runs as a system daemon under systemd, and that's instead of lost automation where you sit there and hit the button every time, it's 24/7 automation, 24 hours a day, 7 days a week, and in fact is ready to scale, and it can be sending out your deliverables, whatever this is, on a scheduled basis by email or on the web, and you go from noob to sage. And that's pretty much Pipulate. And doing your Google Search Console data is just one of the many things that is going to be doable under Pipulate. Next comes SERPs, Search Engine position monitoring, and hand in hand with that, I'm going to do SERPs, and hand in hand with SERPs comes Chrome automation. I should probably say browser automation, but Chrome is such a big part of it that really Chrome automation is seems to be the terminology that everyone's settling on. Oh, Control V. Gotta pick it up like that. And now you can add it like that. Add a little bit of spaces. Chrome automation. Coming soon. Thanks for joining me. Hope to see you again soon. And don't forget to plan out your rows and columns of your SQL databases.